Alrighty, we need to talk about effective nuclear charge, but before we're going to get to that, let's recall our electrostatic potential energy. So we had this formula, UE, which stands for our electrostatic potential energy, is equal to our Q1 times Q2 over R, where Q1 is our charge of one particle, Q2 is our other charged particle, and R is the distance between them. And so the last time we looked at this, we looked at how this changes as we increase the distance between our charged particles. And so what we found is that as R goes up, Q will actually go down. And that's because they have an inverse relationship. So here it's 1, here it's a half. And if they're oppositely charged particles, your UE is negative, which indicates attraction energy. However, to think about effective nuclear charge, we're not changing the distance this time, we're changing the charge. So instead of messing with the R, we're going to mess with the Q. So if this time we have 2Q versus negative 1Q2, and it's the same distance, we're going to find that UE actually goes up. So in this instance, we get negative 1, and this instance, we get negative 2. Negative 2 is more negative, which indicates more attraction energy. And so what we're seeing is as we increase the charge, we have more attraction energy. And we're going to see that's what we have. It's related to effective nuclear charges. We increase the number of protons in our atom. So our effective nuclear charge, or our ZEF, is the formula, and the formula is our number of protons minus our number of shielding electrons. So those shielding electrons are these inner ones right here. And they're called shielding because they're protecting the nucleus in a way that they are repelling. These inner electrons are repelling the outer electrons because electrons have the same charge, so they repel each other. So these outer electrons, in a sense, feel a different level of positivity, a different level of attraction to the nucleus because of these inner electrons. And that's what the effective nuclear charge is calculating, or telling us. It's telling us how much attraction are these outer valence electrons feeling to the nucleus due to their positive charge and their shielding electrons. So for example, on this lithium atom right here, we have 3 protons and we have 2 inner electrons. So this outer electron, this one valence electron, feels a pull of positive 1, whereas these inner electrons don't have any shielding, so they feel the full 3 proton effect of the nucleus. On this fluorine atom over here, we have 9 protons and the same number of shielding electrons, and that's because we're on the same row of the periodic table. If you go to row 2, lithium is on one side and fluorine's on the other side. And what we see is because fluorine has 6 more protons than lithium does, these outer electrons are able to feel more attraction because we increase the charge. The distance is the same, but the charge has gone up. And so these outer electrons feel more attraction to that nucleus. However, let's see what happens when we look at potassium. So we have 19 protons, and if we count up all of these inner electrons, there's one too many right there. 1, 2, 3, 4, 5, 6. There we go. So we have 18 electrons on the inside because we only have one valence electron. And what we see is that we have the exact same effective nuclear charge as we do in lithium, even though potassium has way more protons. And what's going on is that there are so many energy shells that this final very lone valence electron only feels one part of this attraction energy from the nucleus, just like lithium. And so the moral of the story is that if you're looking at the periodic table, if you stay on the same row and you have the same number of energy levels, so the shielding electrons, the inner electrons, stay the same, but the number of protons goes up. As we go across, our effective nuclear charge increases. However, if we go down the column and we see that our shielding is increasing, our ZEF is not affected. Nothing happens with our effective nuclear charge, only our shielding goes up.